Time to review for your quiz tomorrow on the definition of a derivative. So, first of all, what is the definition of a derivative? And that's using the limit. Well, that's saying that f prime of x is always, and you better know this, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Better not forget that one. What is the difference between a tangent line and a secant line? Well, a tangent line is a line that touches the curve at only one point. Touches the curve at only one point, and this gives an exact reading of the slope at that point on the function. A secant line, on the other hand, is something that touches the curve at 2 points. And when it touches at 2 points, that's giving us just an approximate slope, not the exact slope that we would want. And last one, if the slope of a line is 3, what is the slope of a parallel line to it? That means the slope is the exact same. Its slope would be 3. The perpendicular line would be its opposite and its reciprocal. So flip it over a fraction and make it negative. All right, let's continue forward. Now, to actually finding the limits, remember, we're going to use the same formula at the beginning of each and every one. So, how am I going to solve this? First, I got to plug in x plus delta x into this function. If it helps, even write out what would f of x plus delta x look like. To do that, I'm writing it out. Wherever I see an x, I'm now making it x plus delta x and squaring it. In this case, squaring it. This was 4x, so now it's 4x plus delta x. That didn't have an x on the end. So I can just rewrite it just like that. If it helps you to do that first, then go ahead and do it. What I'm going to do now is just plug in everything I know. So, f of x plus delta x, I just did that up here. X plus delta x, that whole thing squared, plus 4 times x plus delta x, plus 7. Now I need to subtract the entire function. X squared plus 4x plus 7. All that is over delta x. From here, I'm just going to keep on simplifying best that I can. I'm going to expand this, x squared plus 2x delta x plus delta x squared. I'm going to distribute the 4 and get 4x plus 4 delta x. Now the plus 7, and now I'll distribute the negative as well. Negative x squared, negative 4x, and negative 7. Again, all still over delta x. I should look for things to cancel out here. The x squared should go away, the 4x's go away, and the 7's go away. So when I rewrite this now, I'll have limit as delta x approaches 0. I have 2x delta x. I have a delta x squared. I have a 4 delta x all up top, all over delta x. So what should happen? I have delta x's everywhere. That means that I can cancel out a delta x everywhere. And what am I left with? I now have the limit as delta x approaches 0 of whatever's left. 2x, a delta x, and a 4. Now that I've canceled out, now I can plug in my 0 for this guy. So when I've plugged in now, that means I just have 2x plus 0 plus 4. That means it's just 2x plus 4 as my answer. Remember, we can use our shortcut to check it. Bring the exponent down, 2x plus 4 as my answer. You will have a polynomial on your test, and you will have the option of doing a second polynomial on your test. All right, let's do another polynomial. Same idea to start. Now, something I should know here when I'm doing this, limit as delta x approaches 0. This is going to be 2 times x plus delta x cubed plus 4 times x plus delta x squared minus 6 of x plus delta x. That's plugging in x plus delta x. If it helps, kind of do something like this. I want to take x plus delta x and literally plug it in for x everywhere. So plug it in for that x, for this x, and for that x when I do it. Alright, so that's plugging in x plus delta x. Now I need to subtract the entire thing. Subtract the entire function. Like so. All this is over delta x. Now, I won't give you a cube tomorrow. If I did, I would help you out with the expansion of it, but you should be able to figure that out anyway. This will be 2 times, this is going to be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. That's just expanding the first part. I'm going to have a 4. This is now x squared plus 2x delta x plus delta x squared. And I have a minus 6x and a minus 6 delta x. That's just this part here. I also need to distribute this negative, so negative 2x cubed, negative 4x squared, and positive 6x. All of this is still over delta x. Yes, this is a big, big, long problem here. So, keep expanding, see what I get. Limit as delta x approaches 0. I'll now have 2x cubed, 6x squared delta x, 6x delta x squared, and 2 delta x cubed. This part here gives me 4x squared plus 8x delta x plus 4 delta x squared. I have minus 6x minus 6 delta x minus 2x cubed minus 4x squared and plus 6x. Still all over delta x, just like we've done before. Look for what cancels. A 2x cubed with a 2x cubed should go away. I should have, with the negative 4x squared, is a positive 4x squared. With a positive 6x is a negative 6x. So, I'm left with a bunch of stuff still. Limit as delta x approaches 0. 6x squared delta x plus 6x delta x squared plus 2 delta x cubed plus 8x delta x plus 4 delta x squared minus a 6 delta x. All over delta x. You have a lot of delta x's, which is good because that means we have a delta x everywhere. It means I can get rid of one everywhere. Delta x gone, delta x gone, delta x gone. All those are now gone. So what I can do now is rewrite what I have left, which is the limit as delta x approaches 0, 6x squared plus 6x delta x plus 2 delta x squared plus 8x plus 4 delta x minus 6. Again, once I've plugged in, or once I've canceled out the delta x, I can now plug in 0. That means this entire term will become 0, so will this one, and so will this one. The only thing I'm left with, 6x squared plus 8x minus 6. And again, check your answer up here. Brought the 3 down, made it 6x, lower it by 1, x squared. This becomes 8x, and this becomes just a minus 6, just like you need it. All right, now, a radical. You're going to have a radical and your choice of maybe doing a second radical on here. This is how you're going to do it. Plug in x plus delta x, so we'll have x plus delta x plus 14 all under a radical, minus just a regular function, x plus 14, all over delta x. You need to multiply to rationalize this. We're going to multiply by the exact same numerator, except in between the two radicals it's now going to be plus instead of minus. And then my denominator needs to be the exact same as the numerator, because I need to multiply by 1. X plus 14. Alright, when I do that, I'm just going to FOIL through. When I multiply the first ones together, it's just going to be, the same thing except without the radical. So x plus delta x plus 14. When I do the last ones, it'll be minus what's on the inside, x plus 14. All over, when I did the middle and the outers, they're going to cancel out. One's positive, one's negative, which is what I like, and everything else stays the same. I'm going to leave this guy just in its factored form. It's not worth trying to distribute it through. Plus square root of x plus 14. Alright? And that delta x was down here as well. Things are going to cancel out. This is a minus x plus 14, so that's the same as saying, I'll even rewrite it out real quick so you can see that. My numerator is now x plus delta x plus 14 minus x minus 14 all over delta x times this square root stuff. X plus delta x plus 14 plus the square root of x plus 14. Okay? What canceled out like we thought? The x and the 14 both go away. All I'm left with is a delta x up top. Well, hey, take a look at this. My delta x's will cancel. That means I'm left with the limit as delta x approaches 0. I still have a 1 up top, and I now have this square root of x plus delta x plus 14 plus the square root of x plus 14. I can plug in 0 for delta x. That means when I do that, I have 1 over the square root of just x plus 14 plus another square root of x plus 14. So I have 1 over 2 square roots of x plus 14. That is my final answer. Again, you will have a square root and your option of doing a second square root. You'll have the same thing for the fractions. You will definitely have one, and you'll have the option of doing a second one on your test. So, limit. As delta x approaches 0, I'm going to plug in x plus delta x And then for this guy, it's just 1 over x plus 4 as it normally was, all over delta x. I need to make a common denominator. That means I need to multiply this guy by the first denominator on both the top and bottom. Again, I can only multiply and divide by 1. I can't do any more than that. And the same on this side. Multiply by x plus 4, multiply by x plus 4. Really, I should put these guys, my original denominators, in parentheses here just to kind of make sure we're not doing anything too illegal. So this is the limit as delta x approaches 0. My numerator here is now x plus 4 for the first guy. My numerator for the second one is x plus delta x plus 4. That's all over this new common denominator of x plus 4 times x plus delta x plus 4. And then I have a fraction. This should all be over delta x. Well, when I have it a denominator with something else dividing by it, I can just put that in its denominator. I can just put my delta x right there. Now all I have to do is simplify. Limit as delta x approaches 0. I now have x plus 4 minus x minus delta x minus 4 all over my common denominator. X plus 4, x plus delta x plus 4, and delta x. X is here going to go away. X and x, 4 and 4. I'm going to be left with, write it out, I'll be left with the limit as delta x approaches 0. I have negative delta x up top. I have x plus 4, x plus delta x plus 4, and delta x on the bottom. My delta x's can now cancel out. There they go. I'll be left with, when I do that, negative 1 over, I got to plug in 0 for my delta x here. So I'll have x plus 4 times x plus 0 plus 4, which is just x plus 4. So negative 1 over x plus 4 squared. Again, you'll have one for sure and your option of doing a second one. All right, and the last one. Find the equation of a tangent line. This is the only problem on the test that you can use the shortcut. So, using the shortcut, let's find the derivative. Bring the 3 down in front. 3 times 4 is 12. Lower that exponent by 1 to make it x squared. Bring the exponent in front. 3 times 2 is 6. Lower the exponent by 1 to get x. And this one, the exponent would have been 1. Bring it down in front. And now I have x to the 0th, which is just 1. So that's all your derivative is. We need to find the derivative, though, at a specific point. That point is when x equals 1. So I need to do f prime of 1. That means just plugging it in. So 12 times 1 squared plus 6 times 1, and then minus 4. So this equals 12 plus 6 is 18, minus 4 is 12. This is your slope if you're thinking y equals mx plus b. So what I should do now is use that, y equals mx plus b, and plug in the things that I know. I know that y from my point was 3. I know m from the derivative was 12. And I know x was 1 plus b. It would really help, though, if I could do simple algebra, right? Actually, just simple addition. 12 plus 6 is 18, minus 4 is not 12. It is 14. So that means this number down here should be not 12 as well, but 14. My apologies on that. So what I do from there, I need to now solve this. 3 equals 14 plus b. Subtract 14 from both sides. Negative 11 equals b. I am not done yet. I have all my pieces. I need to actually write the equation. So it needs to be y equals mx plus b. I plug in my value of m, which I found is 4. I leave my x and y in there, and I put in my b, minus 11. This is what I need to have for my final answer. Well, there we have it. Best of luck, and of course, let's go Bucks.